All right. Hello, everybody. Thank you for joining the Tachyon AMA. I'm Colleen Lavin. I'll be your host today. And joining me, we have got a good lineup today. First of all, we've got the one and only Zach Supalla, Particles CEO and founder. We also have Particles CTO here, Nick Lambourne. I don't know why I had like a very dramatic pause before your name, Nick. Uh, and we have two of the masterminds behind Tachyon. Uh, Eric Berseth, who he has been in charge of most of the software around Tachyon, along with other people. And we also have the one and only Mohit Bhoite. All right, everyone. Thank you all for joining today. So we do have quite a few questions. Some have been submitted to me beforehand, and we'll also be answering questions as you submit them. So if you have a question, just put it in the comments. And if you have a comment, I mean, you can also put it in the comments, but we probably won't read that one aloud. All right. So the first question that I have today, this is one that was submitted to me, and it is, why are you building a single board computer now? This is a pretty big difference from anything you've built before. So why today? Why now?
So, hi everyone. I'm Zach. I'm the founder and CEO, and happy to be chatting about the stuff that we're doing with Tachyon. So, background on this thing. Particle's been around for about 10 years. We have up until this moment been doing connected microcontrollers. And if you look at the history of products that we've created, Tachyon is our 5th generation of device. Our first generation was an STM32F102. Did I get that right? I'm like looking, Mohit. Yeah, okay. Which was a little tiny Cortex M3 controller with 10 kilobytes of RAM. And when you start with 10 kilobytes of RAM, which was sort of the norm for microcontrollers at that point, like everything feels big. And so over the last 10 years, we've been getting into more and more powerful microcontrollers, kind of going with the market. Microcontrollers have gotten more powerful. Now we have 4 megabytes of RAM in our latest 4th generation products. So they keep getting more powerful. And as we approached the sort of high end of microcontrollers, you start to face a decision of like, do you start to get into some of the like there's this funky high end of microcontrollers that are like kind of expensive, or do you just jump over into microprocessors? And we've been debating it for a long time where there might be opportunity for us there. And so we decided with 5th generation, we wanted to take the leap. And when we did so, also acknowledged that like Raspberry Pi has done a really great job of enabling the sort of low end microprocessor world where you're looking for a inexpensive, very accessible computer. And so we decided that we wanted to jump in with something that's a little bit more high end, focus on cellular connectivity, 5G connectivity in particular, and focus on accelerated AI ML workloads, because a lot of the pull we've seen has been getting into things like AI cameras and things of that nature, drones and robotics, which we have a question on, we'll come back to. But Nick, you want to share a bit about where the Tachyon came from?
Sure. I think when we're looking at that market, there was a couple of options we had. This is the 3rd version. I think I think Mohit may have built at least one physical one, and then we pivoted already into that's much smaller module on the back, a 2nd version of this before landing on. I think what I was persuading everybody to do was the flagship of the single board computer market, because why shoot for the middle of the market when we haven't established a position inside it yet? So part of the reason why we're in this kind of crazy Qualcomm chipset is it was the best one we could possibly afford without breaking the bank, and also costing $300. So that was a pretty easy process to go and get there. But I think the other 2 parts of it, if you zoom out of the single board computer market a bit, I think the things that make that product category accessible is open source software, specifically good open source software. Now, the other component that came to us with this module and this chipset that we're using, the QCM 6490. I have to get that right because there's two versions, QCS 6490, which is a Wi-Fi only version. The thing that came to us most about that module is Qualcomm have been investing significant efforts in producing both upstream kernel support for it. They have an initiative called Qualcomm Linux, which is mainlining both Ubuntu and also Yocto distribution for this module. And considering they were spending significant effort in it, I think it's a great thing to piggyback off the top of. So those two things together really jumped us into why we chose this particular module and why this is like the thing we're shooting for at the moment. I think it's I am extremely excited because 8 cores, you know, I have 8 now separate things to do in parallel, where previously I hadn't got such an ambition. And I'm also super interested in the camera capabilities. I think that a lot of the pre-tuned ISP models that you get on standard Android phones are available on this. I think there's up to 30 ISP camera tuned blobs already available. Sadly, they are blobs, but there we go. That's, you know, not everything is going to be perfectly documented open source. But that to me is probably the most exciting thing because there's a wealth of different cameras and things out there we can just plug in. Yeah.
This is the I'm holding the a prior Tachyon. I don't know which one this was, but like this was, so, you know, before we settled on the Raspberry Pi form factor. And so you can see it uses a different kind of a header type of thing. And then also is a smaller module in the back. So this was in an earlier version, we were thinking we were going to go for something that was going to be kind of lower end. And this was more of like an LTE style thing. And we decided, to Nick's point, like we want to go big with this thing and focus on, you know, that sort of places where people really need more power.
Awesome. So I see a really good question in the comments right now. How much are you going to invest in SDKs and developer friendliness?
Nick, you wanna talk a little bit about how you're thinking about that?
Sure, Ken. I'm going to punt it a bit to Eric as well to get him some airtime. So I guess what is an SDK from a developer's perspective for Linux? That's an interesting question because in general, development on Linux is done as a desktop experience. So that involves, you know, everything from compiling kernel modules, using the headers and compilers built into the board, to running Python apps on it with good libraries. And I think that one of the key things there is making sure that there is SDK or API support for all of the features on the board, such as how does the audio work, how is the graphics outputting, how is the ISP connected. I think that's the primary focus we've got, is making sure that all those things are standardized so that everything that you do out of the box just works. And the other side of it, I'll say quickly before Chuck throwing it to Eric, is we're investing quite a lot in the setup experience. How do you get the box? How do you undo it? You know, should be pretty simple, I hope, like a clasp or ripping a ribbon. But that probably should be the most challenging part about the setup experience. Plugging it into your laptop and following through particle setup process, which downloads OS images onto it. I think it's something we've done a really good job of on the microcontroller side. And we're looking to invest significantly in this area as well, just to make sure that the setup process is good. And we can do that because we have access to some of the bootloader tools and things that are directly integrated into the chipset. So we don't need any SD cards or any kind of intermediates. Eric, what am I missing? What do you think's exciting on the SDK side?
Certainly we're going to focus on making this easy to use. And certainly there are aspects of Linux which are, you know, you can get down in the weeds and you can get lost, and it's very difficult and very complicated and esoteric. And so we're trying to rise above that and make the experience a lot easier. So, you know, ARM Linux is just ridden with like device tree blobs and device tree overlays and stuff like that. So we want to make this easy for the user to say, I want to treat this GPIO as a GPIO, or I want to use it as an I2C bus or a camera or something like that, right? So without having a lot of very, very in-depth knowledge, we want our users to be able to just use a camera or use a GPIO or use a Raspberry Pi hat, for example, or a quick or a SparkFun product or some sort, right? So we want those to be easily accessible, and we would certainly like it to be kind of in line with the way that Particle programs things. So very familiar APIs that would be offered inside of the development environment. So you can still publish up, you can still use Logic and Ledger, you can still use location services, you can still subscribe to functions, you can still, share variables, all that kind of good stuff, just in Linux. And, certainly in C++, but also in Python and other languages as they come around.
Amazing. One thing I want to add there is, at least to me, what I see as one of the main points of Particle is removing all barriers to entry, so you can start working on something and actually get to work on the project you're excited about quickly. Because I think we've all been there where you have a device, and I won't name any names here, but if you're working with some sort of embedded device and you end up spending about 6 to 12 hours setting it up, installing drivers, and banging your head against the wall and questioning every single life decision that led you to this point. And for me, the whole point of Particle is making it so you don't have to do that, and you can focus on building what actually matters to you.
Absolutely. Absolutely. That is the key. And so, as I mentioned, you can get into the weeds, but we want to keep everyone above the grass level there so they can see around, right? So yeah. And Linux also offers so many endless libraries and things to actually use in your projects. And so we're hoping to tap into just an infinite possibility of libraries to support everything.
All right, and so I'm seeing quite a few questions here from Jairus, so thank you. I'll start with your first question. Does Particle currently support any medical devices on its platform?
Yes, we do. And I think, stepping back for a moment, talk a little bit about how we think about like sort of prototype to production. So the Particle, one of our shticks is we want to make it easy for prototyping. We also want to make it easy to transition from a prototype into a full-scale production. We make most of the revenue of the business comes from selling our platform to companies operating at scale. And so we want to support every possible use case on it. And if that use case is something that you're scaling, that's definitely something we want to get right. So on our microcontroller platforms prior, we have a bunch of sort of healthcare devices. So the biggest places that Particle's used are what we generally think of as industrial categories, but it's that's pretty broad, right? So healthcare, agriculture, real estate, energy, oil and gas. We do a lot of like methane emissions monitoring is a common use case. We have a pretty wide range of stuff that gets built with Particle. So yeah, we have medical devices on our platform, and with Tachyon, there's a lot of the types of medical devices that we work with prior, things like, operatory equipment, things that are more sensors and controls, because that's microcontroller based. With Tachyon, we'll get into things that, can have cameras and displays, and that's a whole nother category in every industry, right? But like, healthcare medical devices is a very particular one. So some of the other questions there are I'll pass off to the engineering team to talk about that side.
All right, so I will read these other questions. First off, what is the boot to user space time with Tachyon? I think Mohit or Eric, for either of you.
That is, I'm gonna say that is not determined yet, but as fast as possible. It also depends on whether or not you're booting into a GUI or if it's a headless operation. So if it's headless, you get a prompt a lot faster. If it's a GUI, it has to paint the screen and get all the graphical elements in place and stuff like that. Certainly greater than 15 seconds, but less than a minute. So I'm going to be squirrely with that answer because it all depends.
All right. Well, that's the thing about questions at this stage. Sometimes the answer will be, it depends. And that is fine. All right. Can cores be allocated or dedicated to mission critical services that require high fidelity?
Nick, do you want to field this? Because we do have some thoughts about dedicating some cores for non-Linux activities, but maybe Nick could discuss that further, his thoughts.
I mean, I'll give the high level, Eric. It's this chip uses a big little architecture. It has 8 cores on it. It has 1 giant core, 3 smaller ones, and then 4 junior cores. I think they're called gold, silver, and bronze. Is that Qualcomm's terminology for them? There's a CPU scheduler inside the chip. So just stepping back, the chip we're using was, 2021's flagship cell phone architecture. So the design of the chipset itself is to get burst power where humanly possible, but also allow workloads to be migrated back to lower cost cores in terms of how much energy they take. So that predominantly the goal is when it's left by default mode, it moves work around automatically using the Linux scheduler and CPU governor to go and rate the cores up and down and make sure that we only in fact, it clock gates off cores that aren't being used at the moment to create a dynamic environment. There is the ability to lock workloads or affinities to various CPU cores, which you can turn on. However, if you do so, you do lose some of the benefits of some of the thermal management, which is also built into it, because our module doesn't use a fan, which is great for a single board computer if you don't need to go and install it into an enclosure. But it doesn't use a fan because inside it there is a thermal monitor that sits there polling the CPU temperatures across everything and will lock things down. So to answer the question, can you lock workloads to high performance cores? Yes, you can. But if you hit temperature bottlenecks, then those cores will scale back in order to prevent the chipset. Now, you can, of course, add in active cooling if you want of your own to kind of manage that. So yes, I think the answer is a complicated one. Yes, you can. Typically, these chips are used in kind of automatic mode, and Linux does a better job. But if you so wish, you can go and force things into certain cores. It does work. Okay, I know.
I want to use that to quickly. I want to use that to quickly jump off into a couple of topics that I think are helpful for folks who are coming from Raspberry Pi, because I think that there's lots of ways that microprocessors and single board computers can work. Most folks' experiences with Raspberry Pi, and so I think some of the questions we get sometimes are like, how does, for instance, thermals, right, is a question that's come up a bunch in the comments and is worth talking about, because the processor that we're using is a smartphone processor, right? And so one of the benefits of that is that a lot of work has gone into making it work well in an enclosed environment with no cooling, because your smartphone doesn't have a fan, right? And so we get to benefit from that work. We've had a lot of questions pop up in the comments, which are like, how do I attach a heatsink? And our answer is consistently, it doesn't need a heatsink, because it is a processor that is designed for enclosed spaces, but also it also benefits from the fact that there's a module on the bottom for this metal that acts as a heat spreader. And so you get all this good thermal stuff that just sort of works, where I know a lot of folks who are coming from using Raspberry Pis are used to like needing to think a lot about thermal management, especially when you deploy a product out into the field, because you don't know what the temperature is going to be in the environment that it's in. And it's a little bit more intelligent than that because of the smartphone lineage of the processor. The other one that comes up that we have seen is often a challenge for folks who deploy Raspberry Pi based products out into the world ends up being SD cards. So like SD cards are great if you're like writing a little bit of software and running it on your desk, but like in practice, running an OS on an SD card ends up being like one of the more common failure modes for those category devices deployed out into the field. And it has onboard flash, which means like a lot of those problems also kind of go away. And so there's a couple of things that come with the sort of system design that I think eliminate some of the common challenges with single board computers, and that makes this stuff easier for folks who are going to scale.
Amazing. Now we've had a few very in-depth questions, and This one, I think, this next one is just a quick yes or no. Is there support for sleep modes to conserve battery life? Yes, that is a yes. All right. I like it
I was
when we can
curious
have.
whether this team was capable of a quick yes or no, but I appreciate that.
We didn't even have. I thought at least one of you would say the word aloud.
The pressure was applied to simply nod or shake our head.
Yeah. Instead of a simple yes or no, it was a yes. The answer is yes. Next up, how long will the product be supported or manufactured?
So the one of the nice things about this chip, and I'll double down a little bit on the chipset that we're using. So the chipset is called the QCM 6490. To Nick's point, it's basically like the Snapdragon tech that was in top tier smartphones a couple years ago. One of the questions we've seen come up is like, why are we not using the smartphone tech that's in top tier phones today? I mean, that is technically available to us. We could have done that. It would have been so expensive, right? So I think what we're looking for is like the right mix of it's powerful enough for the kinds of things we think people are going to want to do with it, but it's also not going to break the bank. And so one of the challenges with using smartphone chips is that smartphone chips generally have a pretty long or pretty short like EOL time frame, because smartphones get replaced every couple of years. But what Qualcomm's done is pick a couple of these chips and put them as and classify them as IoT chips that get a 10-year life cycle. And so this product will the longevity guarantee of the chips underneath the hood is 10 years. And our history basically is to, we make things as long as people are buying them. And so I think, the silicon shortage in the last couple of years for us and everybody else created some hiccups there, because like there were a lot of chips that we used that just weren't available anymore, that don't exist on the market now in the new silicon market that's formed after that. So every company who made something had to deal with that. But generally with that aside, like we've generally been able to continue to sell products as long as the chips that are in there are available, and as long as somebody keeps wanting to buy them and use them in their products. We recognize folks who are building stuff with Tachyon might make that product for many years, and we want to make sure that it continues to exist as long as you're making a thing that's powered by it. Yeah,
and I will say that I know people who still have things running on Spark cores to this day. So we do have a track record there.
They're still out there. Spark cores are still a thing.
Yeah. And my P0 does not work anymore, but that is user error, not due to particle. Mm-hmm. If I had not destroyed this thing, it would still work. Well, it would still run. All right. Ravi, I'm going to ask your second question first, because I have gotten this question from quite a few people. Any chance of a 16 gig, 20 or 256 gig for a dev Tachyon? So more RAM. Any chance of that in the future? Don't all speak at once.
It's possible. The chipset does support up to 32 gigabytes. We're currently using inside this product a dual or stacked Samsung UFS / DDR4X module, and they do come in larger sizes. What's happening though is as the larger size goes, so does the cost as it keeps going up. So we added in the 8 gigabyte version, which we've seen great take up of. So clearly there's hunger for more RAM. I have a lot of hunger for RAM as well. I think everybody in our company does. We would eat it if it was available for breakfast cereal. So I think we're continuing to look into increasing the RAM size. I'm not sure that my preferred version, I think, would be a 16 gigabyte 128 version. I think that that's in a sweet spot. But I don't install lots of games on my single board computer because I'm not allowed to as a father. So showing a good practice. So I think that might be just
I think your kids would allow you.
Maybe, yeah.
So I think it's worth. I think I want to talk about this because I think the RAM upgrade was like a really good example of why we wanted to go on Kickstarter with this thing. Because one of the questions we've also gotten is like, why is Particle back on Kickstarter? having not done this for 9 years. So we launched originally the Spark Core in 2014. That was 10 years ago. The Electron was 2015, so that was 9 years ago. That was the last time we were on Kickstarter. We've done a bunch of product launches since then, but we weren't using Kickstarter. And the reason we went back to Kickstarter for Tachyon was because one of the benefits we got with Spark Core and Electron on a Kickstarter campaign was that we could engage with the community before the development process was done, to get feedback on what people wanted to do with it. That ended up influencing pretty dramatically the final design and implementation of those products. And so because this is so new for us, we wanted to have that same level of community engagement. Perfect example. The product was spec'd only at 4 gigs of RAM. The far and away, the number one request was RAM. We did a survey, and thank you to all the folks who responded to the survey, asking what do you want, and everybody said more RAM. The survey results were hilariously skewed. It was such a clear signal that everything else on there was hard to figure out, which is why we did a second survey, because if you weren't asking for more RAM, like the RAM question, like clouded every other thing that anybody told us. So the second survey was also useful.
Yep.
But interesting data on that. So like a lot of there was a clear feedback that folks wanted more RAM. And so I think to Nick's point, we really want to make sure that we hit the right like price point mix when we do this stuff. And so part of the reason we started with 4 gigs is because we were like, well, we don't want this thing to be too expensive. I think there was a very good pushback from the community that says, well, if I'm going to be doing development on this thing, I need the memory to be able to do all of those things on this device. And the way we're sort of imagining how people are going to use Tachyon in practice is you might have like a Tachyon that's your development environment that you're using to like write the code and test the code and run the code on your development device that's sitting on your desk. And then as you're like making more of them, then you're going to sort of shut off the desktop environment into the like headless devices that are going to run that software, but not necessarily like run your whole development workflow, which is just going to be on that development device. And so I can imagine this world where you're sort of like doing development on 8 gigs and then you're pushing out to a bunch of 4 gig devices, like where you don't need all of that RAM when you're not running the desktop environment. I think practically speaking, the 16 gig and higher, like I think it'll depend a little bit on once we get this out. We're not intending to announce a 16 gig version in the near future. I think once we get it out in the world, we want to see how people use it and see if the 8 gigs is a limitation. Because although it was the most common request, it still is the case that, I mean, I don't know whether this is a big number or small number. 1/3 of our Kickstarter backers upgraded to 8 gigs. So while it is definitely the most common add-on, 2/3 of people are still using the 4 gig one. And so we want to match what it seems like people are looking for in general.
All right, now this next one seems perfect for the one and only Mohit. Any considerations on having an interface MCU to access JTAG debug ports through USB-C?
Yes, so that has also been a requested feature. Is like, do we have a companion MCU, or is the main module everything? And it's still in the design process. For example, we definitely are going to add an MCU that does all the power-up sequencing, booting sequencing, putting the module in the correct modes. You know, the famous particle 2-button mode has been a classic and has existed in many devices, but executing that on a Linux machine is a very different approach. It requires a different approach. So yes, there will be an MCU. Whether there will be an MCU to do debugging or having direct access to the module, that is still up in the air. Will there be an MCU to do more real-time task management? You know, things that require high-speed GPIOs or real-time control. We're still in the design process, and I think Nick has a few opinions. The community has a few opinions, and we're still listening. And so again, like as Zach had pointed out, this is a Kickstarter campaign, and the whole point of Kickstarter campaign is to listen to our users and what they actually want. And we can assure that if that is a request or a desire for community to have that on Tachyon, then that will be added.
Awesome. All right, this next question, I think I'm going to throw to Eric. What types of security measures are you going to expose as features for Tachyon, like encrypted flash, secure boot, not secure boot, TPMs, etc.? What are we planning here, Eric?
Well, if it did have a butte, it would be like the Close Encounters of the Third Kind in Wyoming.
No,
Column.
I
We
was
start,
personally hoping we would all go
putting
like ignore
potatoes.
my gaff, but okay.
Oh, I love that. Okay. So we're gonna try to adopt a lot of things that are already offered by Qualcomm. And so this is a Qualcomm chip. They do have secure boot in it. They have various mechanisms to make sure that everything is secure all the way from there, like their internal super secret bootloaders, all the way up to the kind of the Android-ish bootloader, which is UEFI-ish, but really not. And then Canonical usually signs their own kernels on top of that. So that's kind of where we're looking at the kind of the end of that trust chain right now. For file systems, we will try to support everything that's in the Linux kernel. So the Linux kernel does have some support for encrypted file systems. Certainly, if you plug in a USD or an SD card into this thing, and you don't want someone just to walk by and pull out the SD card and have a bunch of privates and secrets and stuff like that, I could see where that is a big want, basically. And then also, if someone just steals your device altogether, you don't want to leak secrets, you don't want to leak private information, and so forth. And also, you don't want bad actors executing bad code on your machine. So yes, we are looking at secure methods all through that boot and execution chain.
Awesome. All right. Will Particle's IoT platform provide AB OTA support for the Tachyon? And this is another one-word question or one-word answer. Can we do it?
No, it isn't. No, it isn't. That one's not.
It could be that will.
No, it's not, because it's a question about what is the right way to do over-the-air software updates. I'm gonna for
that is the question as you are reading it, but it as written, it isn't a yes/no question. But okay, and Zach, you may answer the question.
No, I'm not. I'm not actually going to answer that question. I'm just saying it's a longer answer than.
He's just worked on the semantics of the answer.
Right.
Oh, okay. Now, would anyone like to actually answer that question?
Engineering team, yeah, go ahead.
I will start with the answer. So AB boot is basically you choose to run out of, let's just say, an A partition, and then you're updating B partition. When you know that B is there and it's all safe and ready to switch over, then you switch over to it, right? And then A becomes the kind of the backup partition. Android and a lot of the Qualcomm SDK is kind of built around that. But if we're going to be running Ubuntu on top of it, Ubuntu kind of expects a flat file system, like just one big root file system, and then they mount it because it's on a hard drive, and there you go. So an AB boot would require us to rethink our position with Ubuntu and Canonical. And it's not impossible, but right now it is leaning more towards a flat file system instead of an AB boot.
Can I add to that, Eric?
Absolutely.
The
absolutely.
predominant focus we got is Ubuntu desktop. So installs like a PC, complete takeover of all the partitions. You use it. We have OTA functionality that will allow updating of packages. Some of the, but most of that other aspects are managed by Ubuntu itself, who does security updates and things like that. There's a 10-year guarantee with 24.04 that comes with this in terms of the security updates that it gets. I think the other side of that, Eric, is where you get into was when we dual booting a desktop experience doesn't really make much sense, just because the amount of software that you download for the parallel image is just huge, and it rarely is going to change. I think the opposite approach is when we have a headless mode, which is going to be a very large amount of how customers use this product. I imagine that the desktop mode is a great development environment. Like, you can build your app on it, you can test and deploy it, you can version control it, you can use standard desktop and IDE tools. Works great. It looks pretty. But then you can run exactly that software on a headless mode, a bit like you might do with a headless Raspberry Pi. And in that case, AB is a lot more prevalent because the file system looks a little bit more fixed. Now, where we get to in that journey, initially, it's going to be desktop image, as you mentioned. But I do think that down the line, we'll move into more of a managed headless mode. And that's probably going to involve some form of snapshots or AB support such that we can have a reliable rollout. So I thought I'd just tack onto that.
Yeah.
We'll see how quickly we can get there. Any preferences, let us know.
All right. Now, next up, we have a question from Javier. Are you planning to offer a wider choice of antennas to connect Particle devices to the cloud? Or do we have other antennas that we would recommend outside of the ones on the Particle store? Because Javier is having a hard time finding the appropriate outdoor LTE antenna for B524 songs.
Actually, I'll take that one because that's a really specific question about our microcontroller products. Particle currently has worked only with external antenna vendors for all of our products. So we provided FPC antennas or built the antennas into our PCBs. We have an initiative that if anybody needs external antennas, please write into us, where we are bringing out a very high quality IP67 LTE antenna. And we're doing it we've kind of changed our stance on external antennas for one reason, or put the energy into it is the other reason. Our satellite product that uses NTN has a really, really sensitive front end to it. In order to go and access those satellites running 36,000 kilometers away, we need a very high performance tunable antenna. So we've invested in an IP67 SMA bulkhead antenna with extremely good gain across all of the key bands that we need for all of our modules. And there's an opportunity to support that on any of our modules. Now, the priority for going and getting that done, that's TBD. Like, at the moment, it's going to go out with some key modules, and it costs us, quite a bit of money each time we add it to an existing module. So where we get to and how we prioritize that will happen. But for the microcontroller space, external antennas are coming. Very exciting. Now, was there a question about Tachyon as well inside that, Colleen, or just related to?
That was just related to it, but I figured with this group, we did say it was an Ask Us Anything. So
Sounds good. Okay.
I would add a small note there, as traditionally Particle has been supporting product creators who want to ship products at large scale. So with that comes the requirement for certifications. If you are picking an antenna, it needs to be certified. But with a one person or hobbyist, or if you're prototyping, there's a wide array of antennas that you can choose from without having to worry about certifications in particular. And so, yes, as time goes, we will have the opportunity to, explore more antennas and recommend antennas to use for like one person use. But if you're going into certification land, then that's a different conversation. But the fact that Tachyon has modular antenna system, which means you can use the existing antenna on the board or add external antennas, gives you a ton of flexibility in terms of like how you're going to use it. Is it going to be inside a metal box? Is it going to be on your desk? Is it going to be in a vehicle? And you can choose the antenna accordingly.
I think that's an important point, because I do think like certifications end up being a little bit of a snag that often make development harder. And what we want to do, like I'd love to not have to burden our customers with any kind of certification requirements, but unfortunately we don't set the rules. We must certify the things that we do. And so that means that we certify to specific antennas, and the rules basically say that if you replace an antenna with an antenna of equal or lesser gain, then like the certification carries over. Our customers generally certify, but to Mohit's point, like if you're just making one thing, I mean, it's not like the FCC has like, FCC police out there that are like walking around with like, you know, with a handheld, I don't know, something that like looking for people who are putting in like higher gains. So I'm not officially saying that you could put in a higher gain antenna if you were just doing one, because I can't say that. Period.
All right. Okay. Are there plans to make a smaller case, or will it only be the M1 enclosure?
That's Mohit for sure, I think.
Yeah.
I think the nice thing tapping into an existing ecosystem of single board computers is also tapping into the ecosystem of enclosures, which means since Tachyon is compatible with Pi, it means people using or wanting to use enclosures now suddenly have like almost an infinite number of enclosures to choose from. As far as Particle's official enclosure, we don't have plans to go beyond M1, but we do plan on releasing 3D files for, say, smaller, more compact enclosures, or even ask community members to contribute. Like people have contributed their own enclosures. I know Garrett, who is on the chat here, made a really cool breadboard-friendly Electron enclosure that was easily 3D printable. And I can see similar contributions coming from the community when it comes to making Tachyon-specific enclosures.
Yeah. In general, I think like what we'd like to do, I'm going to make a broader comment about accessories and add-ons and stuff like that, is like what we want to do is make accessories when there isn't something on the market that works, right? Because like, you know, we'll be announcing, I'm going to preview some stuff because like if you're here watching our AMA, then you get to learn things that other people don't know yet. So like we'll be doing an announcement probably on Monday with like our last set of add-ons, and we're hoping to have a whole wave of like other things that you can get. But it's mostly not stuff we make. It's stuff that other people make that we're going to make sure we tightly integrate, like we did with Adafruit with the Cricut robotics hat. And we'll make stuff when it doesn't exist. But the thing about enclosures is that like there are a lot of good enclosures that exist already with Raspberry Pi that will work because we're making it fit in the same mechanical footprint. And so I think the M1 enclosure, the M1 enclosure exists because there isn't something like that, right? Like if you're trying to deploy a product with a single board computer, Raspberry Pi form factor, and you want to put it out in a world with a IP67 enclosure that you can expose ports to the outside of the world, but maintain the like do it in a way where you can maintain waterproofing, and you can have there's space in there for a battery and for a hat and for and it's designed to be mounted on a bunch of different places. Like this thing's cool. My favorite part about this product that like is so hard to articulate is like how cool the mounting enclosure is on the back. Like you can mount this thing to anything. And so it exists because that doesn't otherwise exist. So we made it. But like our advice to somebody who's looking for enclosures that isn't this is like use Raspberry Pi enclosures or design something. And you know, at some point, if there's a clear gap in the market where like there's a kind of enclosure that isn't the one we're making, that you can't buy, like, you know, we'll definitely fill those gaps.
Awesome. Next up, any thoughts on the effort to support Yocto versus Ubuntu Core versus Ubuntu? I know this question is much longer. Yeah. I feel like this is an Eric question, really.
Well, I'm going to say Eric has an opinion.
I have an opinion, yes. Well, Yocto is a fantastic environment for embedded devices. It is not user friendly. And so we are trying to optimize the user experience in this and make it familiar with most users. The push for our development is going to be towards Ubuntu. And I think I read Harry's question. I hope I'm pronouncing your name correctly, about Yocto versus Ubuntu Core. And Ubuntu Core, I am unsure the adoption of that. It's been around for probably over 10 years, and I don't know if it really kind of took off. Right now, we're trying to move towards the Ubuntu, the standard Ubuntu offering, because, you know, we have 8 cores in there. It's going fast. We want, that kind of experience. The core is really meant for embedded, but we're trying to kind of bridge it into more of a something more of a desktop type of environment, but kind of can run headless at the same time. So it's leaning less towards Yocto and more towards Ubuntu, just standard Ubuntu. And then, things can change, but we do have a finite resource to be able to work on these things.
So I'll add, Mohit commented while you were talking, Eric, that you were giving a very diplomatic answer, which I think is which is accurate. I think I'm going to give maybe like a less diplomatic, but also, what we want to try to aspire to comment, which is that like a big part of the reason we're leaning on Ubuntu as the primary experience is because we want it to be a big focus for Particle is like really easy onboarding, right? Like you should be able to get up and running and be doing something in 5 minutes, right? And so that's really easy to deliver with Ubuntu because that aligns very well with the way that Ubuntu works, right? Like it's well suited for that. Yocto is not, right? Like Yocto has some real strengths as a platform. Easy onboarding is not one of them. And so we are not advocates of like sort of the unboxing into Yocto experience, because that is, in order for that to be productive, that means you already need to know Yocto. And yes, I know there's folks in the community audience who do, but like that makes things really hard for the average person. What we do want to do is figure out how do we make it such that there is a reasonable transition to Yocto. When we think about, is like, how do you start with an easy experience with Ubuntu Desktop? And then how do you transition onto a Yocto-based deployment at the appropriate time in the appropriate way? And that is a technical challenge we are taking onto ourselves. I would say, like, I don't think we figured out how we're going to do that yet. Because what we also don't want to do is like insert a very painful transition somewhere in your development process, right? And so, but that's what we would aspire to do, is sort of like create a development workflow that has that great ease of use and the guardrails that Yocto applies, and a seamless transition from one model to the other. See if we can pull it off.
All right. Next question. This one's from Darren. Is it fair to think of this as a 2-year-old smartphone that has been enhanced with an NPU? This one's for you, Zach.
I think it is entirely fair. It is perfectly accurate. That is exactly what it is. But I think it's like, but I also want to say, it's funny. Sometimes there's a little bit of like, well, couldn't I do this with a smartphone?
Are you going to, though?
Well, how though, right? Like, I think that yes, we are taking the tech of a smartphone and we are repackaging it, right? And we're doing that with, in some sense, I think the Silicon world is actually all about taking 2-year-old stuff and then repurposing it. So like, let's just, say the quiet part out loud. That's how all Silicon businesses work, is reusing a tape out over and over and over again, right? And so one of our investors, Avidan Ross from Root Ventures, has a phrase that I have stolen from him, but I try to at least give him credit when I use it, which is that IoT is like the peace dividends of the smartphone wars. Right? Basically, that like the term is taken from World War II, right? Where like the modern. Sorry, I'm going to go down this rabbit hole. A lot of the like what we think of as the mid-century modern innovations were like the output of R&D investments that went into World War II. The peace dividends are when you have peacetime after war, what you get, like the economic benefits that came out of that. So like there has been a smartphone war, there have been PC wars, there's the war for Web 2.0 and Web 3 or whatever, there's the AI war. All of these produce peace dividends, meaning that like when big companies are fighting for something, the output is technology that we get to use in other ways. And the Internet of Things is basically the peace dividend of the internet. Like the internet was built for humans to share content, but the existence of the internet can be used to bring other stuff online. And so that's everything that we do, and that's everything that IoT is. Tachyon is very much that. This is the peace dividends of the smartphone wars, meaning like we're taking silicon that was created to try to make the Samsung Galaxy series competitive with the iPhone, right? And we're taking that and repackaging it into something that you get to use as a single board computer for for whatever application that you want to use. And I think that's also true. I'm going to tie, Darren had two questions, the first one and the second one. Neural processing is a very greenfield category right now. What are your short-term goals by including one? It leads into that, right? Like it also has an NPU, which is sort of an output of like the wars for AI accelerators in the silicon world right now. Well, what does that mean? What can you do with that? Well, I think the applications we're seeing interest on are computer vision, audio classification, robotics, drones, a little bit LLMs. I'm going to issue a challenge to anybody who's watching this live or following. Give me a really good use case for why you want to run an LLM on a device. And yes, it can run an LLM, a small enough LLM, but like, I do find that there's a little bit of like, but why? But why? What are you trying to build? Tell us. I actually really want to know. I don't mean to present that as entirely skeptical, but I
can tell you on.
Okay, go ahead, Colleen. What do you want an LLM on a device for?
Okay, so I last year built a project that analyzed me on stage, rated me, and heckled me, and it was far too primitive. And I would actually like to add something that is small, compact, or that's the same word, but also intelligent enough that I don't have to pre-write my own heckles. So that is what I would like it for. And yes, it is ridiculous, but that is what I will probably be using the Tachyon for when I first get it.
Okay, fair. All right. So Colleen has found the use case for an LLM on the device, which is a Heckle Bot. So
yes.
We goal established. So we're gonna try to do that. But I do think one of our beliefs when we look at these, like the early stages of this kind of peace dividend thing, is that you have something like an NPU, and it becomes available because of as a consequence of other things happening in the industry, and it's just this thing that you have now. And then what are you going to do with it, right? So like we have ideas about what people are going to do. I think computer vision is probably like the biggest, and you can do computer vision on a CPU. You don't need an AI accelerator, but you can do so at higher frequency, higher resolution, better performance, better power, less power hungry. You can offload it onto that and then use the CPU for other things. So there's a bunch of benefits. But I also think that people are going to use it in ways that we don't expect. And some of, part of the journey is delivering this into the market at a point where like the use cases are probably fuzzy. And like the reality is we're not going to figure out the good ideas. You're going to figure out the good ideas. Other than Colleen. Colleen figured out the good idea with the LLMs. It's the Heckle Bot. But like, I expect that we will end up listening to you more about what you want to do with it than we will do telling people what they're supposed to do with it, if that makes sense.
I will also add, if you want really bad ideas, go follow Zach on social media, especially on Particle, because he wants to solve.
TikTok.
It turns out that if I film videos of really stupid IoT products, people watch those videos. And so that means I have to do that now.
Yes.
And so there will be more. There's videos out there of my raccoon, how we need to get rid of my raccoons that are eating my garbage. None of them are good ideas, but like people watch the videos. So,
well, also I would argue that I'm not arguing that they are good ideas. That's silly. However, I would say a lot of what gets people to work on a project is not because the idea is good or because it scales most of the time. A lot of what gets people to work on a project is, oh, this is a really annoying problem in my life. I guess I will just over engineer a solution to get these raccoons to go away.
Yeah, that's true. I remember in the early days of the micro Wi-Fi, like Spark Core, Photon, definitely the most common use case was cat feeders. I remember like when we first launched on Hackster, the very early days of Hackster, and we said like, show whatever your project. There were like 100 projects, and at least 5 of them were cat feeders. And I thought that was very funny because I was like, there is something very interesting. I still think this about the fact that like the most common project that engineers will build is a cat feeder, but somehow the market has still also decided not to like serve the need of people who are trying to build cat feeders. And I think this is because engineers have cats, and like it's a very funny dynamic that like creates this project world. But I do think, to your point, Colleen, like people start working on stuff with hobby projects that are fun and something you want to do, you want to learn, you want to build something, you have a particular problem, and then those turn into real products, right? Like a lot of the things that people do with Particle that are out in the world as products you can use or buy are like started as, as hobby projects that just morphed over time. So.
One of my favorite examples of that is always Maple IoT, which is this guy named Jeff who his hobby is making and selling maple syrup. And he started a whole business because his maple syrup sugar bush, which is what they call the giant tanks, by the way, but his sugar bush was far away from his house, or at least inconvenient enough that his wife was getting very annoyed that he was going over there like every day when they had 3 small kids. So he built this tool, casually started mentioning it at maple syrup conferences, and everyone wanted to buy it from him. So he has a whole business now. And I've had his maple syrup. It's really good.
I love that they're maple syrup conferences. That makes my favorite part of that story is that they're maple syrup conferences.
Oh.
There are maple syrup reserves even.
There are. Well, one time I went to a candy and snack conference. It was great. I did have to pretend that I worked at a candy shop. And there might have been some light forgery involved in getting me a badge for it. But if anyone asks, I work at a candy shop. But I have one last question that was actually one of our first questions. That's right, Garrett. We're finally getting to you.
Oh, no.
I keep seeing drone thrown about as a project idea. Is there finally hope for the particle charm?
I like Garrett. Garrett, I know you're listening right now, and I like that you're continuing to chase me down on this 10 years later. Thank you for holding me accountable. The context for for folks who aren't Garrett or like Mohit, and that's probably the 3 of us that have any idea what this is referencing, is in the very early days of Particle, I had an aspiration that I would find personal time to take, I guess it was probably the Spark Core, the Photon, and make a little drone out of it. And it was called, we still name everything after particles, but it was called Charm. Like a quark, right? Like Trump. Yeah. And I had an idea that I was also going to make a robot, and it was going to be called Strange, because if you're going to have charms, you have to have strange. That project went as far as me posting about it on the forums and then stopped, because it turns out I don't have personal time. But like, I do think it is a great, so drones and robotics has been a big pull for Tachyon. It wasn't something we necessarily were thinking all that much about when we launched it. That's definitely one of the learnings when we go out to market with it. And so we're doing some stuff like we're talking to the ROS community and figuring out how we can make sure that ROS is well supported on Tachyon. There's a community around open source drones, PX4, that I've been chatting with the folks at Drone Code, which manage that community. And like one of the things I would love to partner with somebody on is and so I have on my list to reach out to some of the folks who do this, is making a Pixhawk like flight controller hat. I don't think we're going to do that, but I would like to find somebody who's in the Pixhawk community who wants to build that, because it would be a good, like, autonomous drones and robotics are a good use case of this technology, right? You get kind of all the stuff you need, and so that is something we'd like to support and work with those communities on building. And so maybe Charm and the unannounced Strange will come back as a now that we've got the right tech for it.
Okay, I just don't see why you're not calling a drone up, like the up-down drone. Drones go up and down.
Is the flying one and down is the walking one. Yeah, that's better. Yeah.
Drones go up, Zach.
I think the problem is we were naming them after particles, and yes, quarks are up and down. But I think if it was up,
Charm is not a particle. Charm is also a quark.
I know, but okay. Anyway, it's all nerdy science references.
Well, we are in the quantum age, so it has to be something entangled, right? And
that's true. Well, look, Tachyon is Tachyon's a fictional particle, so we've clearly run out of actual particles to name things, and so we're into fiction already.
Yes. All right. And I believe that's everything. Adrian did ask how much does it weigh again, and I believe that answer is 48 grams. Luke is correct. So we have 1 minute left. Is there anything the lovely panel would like to say in your remaining, actually it is now 12. Is there anything you guys would like to say to close this up?
Yeah, I think like we're about a week away from the campaign closing. So I think Thursday next week is the last day of the 30-day campaign. When the campaign closes, we go heads down to go actually make the thing, right? And deliver to you all. So, but that said, while the Kickstarter campaign is this moment where we're like doing this live and we're online, like we're going to be listening and gathering feedback throughout the development process. So it's not like it stops when the campaign is closed. During the last week, we do have an announcement coming out next week about add-ons. It'll be fun, and so we're working on that and pushing that out. And then next week is really that kind of final push to so tell your friends, sign up for the referral program if you haven't already, and then lots more work for us to do to get this thing out to you all and make the software experience great. And that's not just the work that happens before we ship it; it's the work that happens once it's in your hands, and we keep expanding on it. Right, like this isn't a product where the development process ends when it ships. That's just the beginning. So looking forward to working with our community and our user base on Tachyon to make this thing great.
All right. Thank you so much to all of our panelists and to everyone who showed up, asked questions, and listened to us today. I hope everyone has a wonderful day. All right. Bye, everyone.
Bye.
Bye. Thank you.